Hello everyone, welcome to today's tutorial video on Chapter 7, Chemical Formulas and Their Names. Now, I don't know about you, but I've always been curious about why chemical formulas are named in the strangest way possible, an example being tetraphosphorus decooxide. However, there actually is a method to the madness of naming these chemical compounds, and today I will teach you the method to this madness and how to properly name all the chemical compounds. Alright, here is the outline of my video. I'm starting here with the intro and I'll work my way through each of these topics until I get to my final thoughts, which will just help wrap up this entire video. To the left of each of these topics are the time and where they start in the video. So let's say you already know about monatomic ions, but you need to learn about binary ionic compounds more. You can just skip to the point of the video where the binary ionic compounds are, and you don't have to just sit through the video just like, oh, I already know this. You can just it'll help save you some time and get to exactly where you need to go. Alright, here's a quick example. Let's say you have an ion of the element K, or potassium. First you just write the name of the element, potassium. Then you write either A cation, B anion, or C just ion. Potassium is a metal, so you'd write either cation or ion. I'm going to write cation. And there you go. That is the name of a monatomic ion that is potassium. Alright, so our next subtopic is binary ionic compounds. So what is a binary ionic compound? A binary ionic compound is made up of two elements, one of them being a metal and one of them being a nonmetal. Alright, so how do you write the formulas for binary ionic compounds? For this step, it'll be very helpful to have your periodic table handy. For this first example, I'll be doing is bromine and sodium, Br and Na. The first thing you do is write them in order that they would be bonded. The metal always goes before the nonmetal, so it would be Na, Br to start. Then, using your periodic table, figure out what the charges would be for each of these in their most natural state. For sodium, you can see right here, it would be a positive 1 because it wants to lose 1 electron to become a noble gas. Bromine, right there, would be a negative 1 because it wants to gain 1 more electron to be like a noble gas. Then, what you do is you take these and you crisscross them, and that is how you write the formula. You take the charge from the other element, in this case it'd be 1 and 1, and write it like that. That is the formula. For ionic compounds, binary ionic compounds, you would always reduce the subscripts at this point. Well, this is just 1 and 1, so you'd write Na, Br, and that would be your formula. Now let's say this would not be accurate for so if you had sodium and bromine bonded together, but let's say bromine wanted to have a negative 2 charge. Well, you'd still do the same thing, except now sodium would be a 2 and Br would still be 1, and that would be the formula. Again, this is not correct. I'm just saying hypothetically if bromine wanted to be a negative 2 charge. For our next example, we have barium and sulfur. So first, write BAS. So you have the basic formula. Then go and fill in the charges. BA, as you'd see right here, would be a positive 2 because it wants to lose 2 electrons. And sulfur, right here, would be a -2 because it wants to gain 2 electrons. Then you do this crisscross method. So you have Ba2, S2. Now here's a scenario that is unique to binary ionic compounds. This is not a correct formula. You'd reduce the subscripts. You don't do this with covalent compounds, you only do this with binary ionic compounds. 2 and 2 can be reduced to 1 and 1. So the final formula would be BAS right here. Not this. Alright, now that you know how to write the formula, how do you name these compounds? Well, all it is, it's very simple for the non-special cases. All you do is you take the name of the first element plus the name of the second element plus "ide." So I'm just going to give you a quick example. Strontium and fluorine from our how to write the formula section. Now for this, what you just take the name of the first element, strontium, then you take the name of the second element, fluorine. Now here's where it differs a little bit, and you have to include the "ide." You would chop off the end of the element. So for fluorine, you get rid of the "ene," and you would add the "ide." And then that is the name of your compound, strontium fluoride. Pretty simple, pretty straightforward. I want to give you one more quick example. How about if we do Na and F? Take the name of your first element, sodium. Then you take the name of your second, fluorine. Chop off the ending, remember, chop off the "ene," and add "ide." Sodium fluoride. Now on to naming of some of the more special names of binary ionic compounds. Now these aren't necessarily irregularities, it's just something that you'd write a little bit differently because their charges have to take an effect on the name, and you have to write the charge in the name. This happens primarily with D-block elements. And for naming this sheet, some common polyatomic ion, the polyatomic ion sheet, the back side of that sheet is going to be particularly helpful with naming these compounds. Now I was going to start with a quick example. Alright, here is the next example. I'm going to give you some time to figure this one out on your own. It's Mn, which is manganese, and phosphorus. Alright, if you haven't figured it out by now, you just pause the video and take some time to figure it out. Alright, remember, these excuse me, the second element is the same as what you would do with the last naming. It would just be phosphide. This would be phosphorus minus the ending plus "ide." Now, for manganese, this is where it's a little different. Phosphorus has a charge of -3. And there's only one phosphorus in this compound. So, you take -3 times 1, which is pretty simple, -3. This manganese needs to have a -3 charge to balance it out. So you go onto the sheet, look for manganese, here it is, Oh, look, that one has a -3 charge. There it is according to the old system. You don't need to worry about that right now, unless you want to. And you go over here. It's just manganese with the charge and a Roman numeral in parentheses. All the namings for this, these special names, is just the element plus its charge in parentheses. So you would write manganese that's charge 3 phosphide. So that is the name of this compound. So overall, pretty simple. There's not that hard to remember how to name or write the formula of binary ionic compounds. Alright, next on the list is binary covalent compounds. Now, what is a binary covalent compound? Well, it is a covalent compound which is two nonmetals, and a way to remember this is bi equals 2, hence the name binary covalent. So how do you name these compounds? Well, you use a set of prefixes that I've written out right here. Mono, which is 1, di is 2, tri is 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, and deca 10. So how do you use these prefixes? Well, what you do is you put them in front of the names of the elements in your compound. So like right here we have nitrogen and oxygen. What you do is you'd find the number of nitrogens in the compound, which there are 5, and then you use the prefix for 5 right there and the prefix for 2 right here. But before I go into explaining that, I am going to explain why I have a box around the "ide" right here and why that is not nitrogen oxygen. The last element in these compounds always ends in "ide." You chop off the ending and you insert "ide" on the ending. So now I'm back to explaining why, how to use the prefixes. Well, what you do is you find the number in the compound. Nitrogen has 5. So you go over here. Oh, penta is the prefix for 5. So you write penta here. Pentanitrogen. And then you look up here. Oh, that's 2. What's prefix for 2? Di. Pentanitrogen dioxide. And that is the name of your compound. Now, there's one major exception. Mono cannot be first. And now what that means is, let's say there is 1 nitrogen in this compound. You would not write mononitrogen. You just write nitrogen. So one major exception when naming binary covalent compounds. Now on to a couple of examples.